Okay, so last night I asked you to do the first 18 multiple choice. So number one, which two characteristics of light can best be explained by the wave theory of light? So reflection and refraction. Reflection happens with particles, so it can't be that. Reflection and interference. Reflection happens with particles, so it can't be that. Refraction and diffraction. Again, refraction happens with particles. It's going to be interference and diffraction, okay? Interference and diffraction, because waves interfere and waves diffract. And particles, well, to this point, we don't think they do. Which phenomena can be explained? I'll get back to what I mean by that when we get to quantum. Which phenomena can be explained only in terms of the particle model of light? The only one of these that can be explained by the particle model of light is the photoelectric effect. Okay? Number 3, a monochromatic light incident upon a photoemissive surface emits electrons. If the intensity of the incident light is increased, the rate of the electrons. So if you increase the intensity, you're increasing the number of packets that you're sending in to hit the surface, and so that's going to increase the number of electrons that get released. So the rate, how quickly how many electrons come off in a given period of time, is going to increase when you increase the intensity. Okay? When incident upon a given photoemissive surface, which color of light will produce photoelectrons with the greatest energy? So the photoelectrons that are going to have the greatest energy are going to be the ones that get hit with the light that has the greatest frequency, because E of a photon is equal to HF. So the greater the frequency, the greater the energy coming in, which means the greater the energy of the photoelectrons. So the ones with the greatest frequency, which will be the ones with the lowest wavelength, because remember C equals F lambda. So the ones with the lowest wavelength are these dudes up here. So of your choices, it should be violet, blue, green, depending on what's down here. So we switch back and we look red, orange, violet, green. And so violet is the shortest wavelength, which will be the highest frequency. And so that'll be the one that'll have the most energy in the packets of the photons coming in, which means it'll have the most leftover energy, because remember, EP is equal to, EK max is equal to HF minus WO. WO is the surface, it isn't going to change. The bigger the F, the bigger the EK max. The threshold frequency of a metal surface is in the violet light region. Which type of radiation will cause photoelectrons to be emitted from the metal's surface? So if the FO is in the lambda O is in the violet region, then anything, and that means it has a tiny wavelength, then anything with a larger wavelength should have a smaller frequency. And so anything with a smaller wavelength will have a larger frequency. So it's anything that's below violet in the electromagnetic spectrum and in wavelength-wise. And what's below violet in the electromagnetic spectrum, what has more energy is ultraviolet. All the rest of them have less energy. Number 6, the work function of a photoelectric material can be found by determining the minimum frequency of light that will cause electron emission, and then doing what to it? So you have FO and you want WO. I think you should probably multiply it by Planck's constant, choice 4. Number 7, the work function of a metal is 4.2 electron volts. If the photons with an energy of 5 electron volts strike the surface, what's the maximum kinetic energy? So HF is 5 electron volts, WO is 4.2 electron volts. What's EK max? It should be about 0.8 electron volts, choice 2. Number 8, the threshold frequency of a photoemissive surface, so FO, is 6.4 times 10 to the 14th. Which color light, if incident upon the surface, may produce photoelectrons? So light with a bigger frequency, which means light with a smaller wavelength. So your first step is to find out what is the wavelength of this sorry, I'm doing it in my calculator, of this light. So it's 2.9979 divided by 6.4 to the 14th, and you get a wavelength of 4.68. So 4.68 is going to be blue, and so what type of energy will emit light? Anything that has a higher frequency than blue, which means anything with a lower wavelength. And so it must be the blue, because green and all of the others are going to have a higher wavelength. Okay? The next set, 9 to 13, are based on the following. Photons with an energy of 3 electron volts, so that's EP or HF, strike a metal surface and eject electrons with a maximum kinetic energy of 2, so that's electron volts, so that's EK. So you have your HF and you have your EK. So the work function should be the difference between them, right? If you have EK and you have HF, take this over. It should be 3 minus 2. It should be 1 electron volt. Choice 1. Number 10. If a photon had a higher frequency, what would remain constant? So if the F and the HF got bigger, the EK would change, but the WO is dependent upon the surface. So it should be the energy, I should look at the choices. The energy of the photons, nope. The speed of the photons, the kinetic energy of the electrons, the speed of the electrons. So the kinetic energy is going to change if the F goes up. The energy of the photon is going to change if the F goes up. The speed of the electron is going to change if the kinetic energy changes. What doesn't change is the speed of the photons, because that's light, and it's 2.9979 times 10 to the 8th. If the photon intensity were decreased, then there would be, the energy isn't going to change. If you change the intensity of the light, all you're doing is changing the number of photons going in, which means you're decreasing it, which means you should decrease the rate of the electron emission. Choice 4. Compared to the frequency of the 3 electron volt photons, the threshold frequency for this metal is lower, because the WO was 1 electron volt, and they're both equal to HF, so it should be lower. If a metal with a greater work function we use, the photon energy remains constant, the maximum kinetic energy should decrease. So if WO gets bigger and HF doesn't change, then EK max should be smaller. All right, and then your last set. Base your answers 14 to 18 on the following information. Photons of wavelength 2 to the negative 7 meters incident upon a photoemissive surface whose WO is 6.6 to the negative 19 joules. The speed of the photons, well, they're photons, they're light, so it better be 3 times 10 to the 8th, 2.9979 to be exact. Maximum kinetic energy of the photoelectron, so you're going to do 1/2 mv squared, where m is 9.109 times 10 to the negative 19. Oh wait, I back up, sorry. Maximum kinetic energy, I take that back. No, so you have EK max, so you're going to rearrange it for V. Okay, so multiply by 2 and divide by that 9.109, and you should get, work function. Oh, so kinetic energy. You need to do EK max equals HF minus WO. Sorry about that. So find your frequency, subtract your WO, and get EK max. I'm ahead of myself in the questions. And you should get choice 3. I'm assuming I'm on the right question now. You should get choice 3, 6.6, no, sorry, choice 2, 3.3 times 10 to the negative 19. Okay, I think I'm on the right question now. If the frequency of the incident photon is increased, then the EK max should increase. HF goes up, EK max should go up. If the intensity of the incident photons decreases, the number of photons going in decreases, then the rate should decrease. And the last one, photons of the same wavelength are incident upon something with a lower work function, then the energy of the photoelectron should be bigger, because if WO is smaller and HF stays the same, EK max should be the same. Okay, so those were your 18. Sorry about messing up number 15, I was solved.